Good morning, children. Now we'll continue with some three problems. Actually, we have this problem in scalar product. These two are the problems of addition of vectors. So, actually, these should be solved by using the formula of cos theta of scalar product. So, we are doing those two problems here. This problem is from scalar product. With these problems, we'll complete the scalar product between two vectors. That topic will be completed. Next, we'll continue with vector product between two vectors. Now, what is this problem? A, B, C, D are the position vectors of four coplanar points. So, in the plane, you have 4 points A, B, C and C. A, B, C and D. And then their position vectors are A bar, B bar and then C bar and then D bar. D. 4 points are there. Now, you must, and you are given two relations like this. A minus D dot B minus C is 0. And then B minus D dot C minus A is equal to 0. These are also given. You must show that the point D, the point with position vector D, represents the orthocenter of the triangle with vertices A, B and C. So, in the solution, first we'll take the points A, B, C, D as OA is equal to A or A is equal to, let A is equal to OA is equal to A, B is equal to OB is equal to B, OA is equal to A, and then capital B is equal to OB is equal to B, and then capital C is equal, capital C is equal to OC is equal to C, and OD is equal to the point D. Like this we'll take. Now, what is given to us? You are given that A minus D dot B minus C is equal to 0. So, what is A? A is OA minus D is OD dot of B. B is OB. OB minus OC is equal to 0. So, that means what is OA minus OD? DA vector. It is position vector of terminal point minus position vector of initial point. So, it is DA vector. So, DA dot, what is OB minus OC? It is CB vector. So, DA dot CB is equal to 0. That means DA is perpendicular to CB. DA is perpendicular to CB. So, you have CB. This is CB or BC. For this, you have DA. So, through A, you are drawing one vector. So, this is D and so this is DA. DA is perpendicular to BC. So, from the given equation, first equation, we proved this. Now, we'll take the second one. Again, you are given that, what is it? It is given that B minus D dot of C minus A is equal to 0. So, if you simplify in the same manner, you will get dB dot AC is equal to 0. So, that means dB is perpendicular to AC. So, that means AC, for AC, dB is perpendicular. So, this is perpendicular to AC. So, for these two lines, D is the common point. So, and these are perpendicular. So, and they are passing through the opposite vertex. So, this is the altitude. So, AD is the altitude. So, from these two, you can say that, so this implies that DA is the altitude. DA is the altitude through A. DA is the altitude through A. And from this, you can say that DB is the altitude. DB is the altitude through B. DB is the altitude through B. So, in both the altitudes, we have the point D in common. So, D is common in both the altitudes. D is common point in both the altitudes. D is the common point in both the altitudes. So, therefore, the point D with position vector D, that is OD, is equal to D. The point D is the orthocenter, because we know that orthocenter is the point of intersection of altitudes. So, D is the common point in both the altitudes. So, the point D is the orthocenter of the triangle ABC. of the triangle ABC. So hence it is proved. So like this we do. First take the points as A, B, C, D, A minus D, and then you simplify like this, you will get like. Okay, now first problem is alpha, beta, gamma are the angles made by the vector with the coordinate axis. So when you take the coordinate axis, x-axis, y-axis and z-axis, first problem, this is x-axis, y-axis and z-axis origin. So there is a vector. What is it? 3i minus 6j minus 2k. So there is some vector like this. So this some vector. Suppose I am drawing like this. So this vector, when you draw here with origin, so it makes some angle. Suppose this vector, equal vector I am drawing here. Then what happens? It makes some angle alpha with x-axis, beta with y-axis and gamma with z-axis. That is what is given in the problem. So what is the angle alpha? So angle alpha is nothing but the angle between this vector. Suppose this vector is A. And we know that the unit vector along x-axis is I. So the angle between A and I will be the angle made by A with x-axis. Similarly, the angle between A and J, along y-axis we have J. So the angle between A and J becomes the angle beta. And then angle between A and K will be the angle made by the vector A with the z-axis. So that is gamma. So like that we do. So what we do is, here he has given, we take the vector, first problem, we'll take the vector as A. Let A is equal to 3i minus 6j plus 2k. Alpha, beta, gamma are the angles made by this vector with the positive directions of x-axis. So cos alpha is equal to A dot I by mod A into mod I. What is A dot I? A is this. This dot I means A is 3i minus 6j plus 2k dot I. So for I there is no j and k. So 0j plus 0k. It is like 0j plus 0k. So the value is just 3 into 1. 3 only. So we'll write only 3. So 3 by modulus of this. 9 plus 36. 9. 36. And then 4. 49. 7. So it is 7. And mod I is 1. So cos alpha is 3 by 7. Similarly, cos beta is equal to A dot j by mod A into mod j. Mod A into mod j. So that will be minus 6 by 7. And then cos gamma is A dot k by mod A into mod k. Mod A into mod k. So that will be 2 by 7. So these are the angles. So directly we can write like this. Okay, now in the second problem, find the angles made by the straight line passing through these 2 points. So here instead of giving some vector, in the first problem he gave it one vector. Now he has given some straight line is passing through 2 points. So what we do, we'll take the points as A and B and we'll find AB vector. We'll find AB vector, that is OB minus OA. AB is OB minus OA. So that is your vector A now. And then the same procedure. But here the angles, if you take them as alpha, beta and gamma, then alpha will be cos inverse of, like that we should do. Now we'll do that problem. So suppose that OA is equal to A, OB is equal to B, like this. In the second problem, let OA is equal to, A is equal to, what is the point? I minus 3j plus 2k. And then B is the point, OB is equal to, B is equal to 3i minus 5j plus k. So you find the vector A is equal to, AB is equal to OB minus OA. OB minus OA. You have learnt all this in addition of vectors chapter. So OB minus OA, that is 2i minus 2j minus k. So this is your A vector. Now if alpha, beta, gamma are the angles, if alpha, beta, gamma are the angles made by the straight line, straight line AB. Straight line AB. So we'll draw double arrow like this. So straight line AB is having these 2 points. So this vector, angle made by this vector with coordinate axis will be same as the angle made by the line with the coordinate axis. So angle made by the line is same as the angle made by the vector with the coordinate axis. So alpha, beta, gamma are the angles made by the straight line AB with the coordinate axis, with the coordinate axis, with the coordinate axis. Then you'll have alpha is equal to cos inverse of, because here in the first one he asked to find cos alpha, cos beta, cos gamma values. So directly we wrote the values. Now here you should find the angles. So in terms of angles, the formula becomes cos inverse of A dot I by mod A into mod I. So that will be equal to A dot I. A dot I means just 2. 2 by root of 4 plus 4 plus 1, 9. So that is 3. 2 by 3. Cos inverse of 2 by 3. So it is equal to cos inverse of 2 by 3. Similarly, beta will be equal to, so beta is equal to cos inverse of A dot J by mod A into mod J. So that is equal to cos inverse of minus 2 by 3. Minus 2 by 3. Similarly, gamma is equal to cos inverse of A dot K by mod A into mod K. That is equal to cos inverse of, so this is minus 1. So minus 1 by 3. So these are the angles. The angles alpha, beta, gamma are given by this 3 values. That's all. So that is the answer. With this we completed the scalar product between 2 vectors. Now we'll learn about vector product. Vector product between 2 vectors. How is it defined? So first listen to all the properties and then we'll summarize. So how is the vector product between 2 vectors defined? So suppose that A and B are non-zero, non-collinear vectors. They should not be collinear. If they are collinear, A cross B will be 0. So we define A cross B, the cross product. Another kind of product called as cross product between 2 vectors is defined as mod A into mod B into sine of angle between A and B into n cap. What is this n cap? N cap is the unit vector perpendicular to the plane containing A and B. Suppose A vector is here, B vector is here. Then n cap direction is like this. So the rotation should be in the right hand thumb rule, like right hand rule. According A, B's and n cap form a right-handed coordinate system. So A, B and n cap direction will be like this. So you know the right hand thumb rule. So rotation, when you use your right hand like this, A, B rotation is like this. N cap direction will be perpendicular to the plane. Suppose the plane is containing A and B. These are 2 vectors are here. N cap direction is this. It is in this direction. From the plane upwards, it will be upwards and it is perpendicular to this plane. So A, B, N cap form a right-handed system of vectors. So this is the definition. You have learned dot product. No, A dot B is equal to mod A into mod B into cos of angle between A and B. This is just a number, but here it is a vector. All this is number, but into n cap vector is there. So it is, because it is a vector, it is called as a vector product between the 2 vectors A and B. Because we denote it by this symbol cross between them, we also call it as cross product between the 2 vectors. So this is the definition, learn by heart. Now what is mod of A cross B? This formula is again very important. When you take modulus of this is positive, sine of angle between any 2 vectors is again positive. So mod A into mod B into mod of sine of angle between AB into mod of n cap. Because n cap is a unit vector, its modulus is 1. So the value is this. So mod A cross B is mod A mod B into sine of angle between A and B. Sine of angle is always positive here because the angle lies between, this angle theta lies between 0 and 180 only. 0 and 180. So that means they lie in first quadrant or in second quadrant. In both the quadrants, sine is positive. So sine of angle between AB is always positive. So from this we learn another formula. This is one formula that you have to learn. This is another formula. And then from this you find out sine of angle between AB formula as mod of A cross B. Mod of A cross B by mod A into mod B. So this formula also you have to learn. So mod A cross B formula, then sine of angle between AB. There are some problems where you will find the angle, sine of angle between two vectors A and B. Now next is A cross A. Now in this formula when you substitute B also as A, you will get A cross A as mod A into sine of angle between A and A into n cap. So what is the angle between A and A? Angle between A and A is 0. So sine 0 is 0. So this is equal to 0. A cross A is equal to 0. Whereas in dot products, A dot A is equal to mod A square. A dot A is equal to mod A square. Whereas A cross A is 0. When the two vectors are same, its value is 0. Now in the same way, I cross I will be 0. J cross J is 0. K cross K is also equal to 0. Next is I cross J. I cross J is equal to, so we were discussing this about the vector product of two vectors. So A and B are two non-zero vectors. Then A cross B. A cross B is defined as mod A. This is the definition written as A cross B. A and B are two non-zero, non-collinear vectors. Because if the vectors are collinear, then what happens? Angle between them becomes 0. When the vectors are in the same line, then the angle becomes 0. So sine 0 becomes 0. So they should be non-collinear vectors. Then the cross product of A and B written as A cross B, you must read it as A cross B, is defined as the vector mod A into mod B into sine of angle between AB into n cap, where n cap is the unit vector perpendicular to both A and B, such that A, B, N form a right-handed system. So you know right-handed system means A rotation is from A to B and then B to C. The rotation will be less than 180 degrees. There is some definition that is not necessary. So A, B, N cap form a right-handed system. In general, if A, B, C form a right-handed system, A, B, C form a right-handed system, when the cyclic order is maintained, A, B, C, next B, C, A, next C, A, B. If that order is maintained, then they all will form the right-handed system. If any two vectors are interchanged, then they form a left-handed system. So A to B and then B to C, then C to A to B, like that. When that order is same, cyclic order is same, then they form a right-handed system. If any two vectors change their direction, then they form a left-handed system, like that. So A cross B, this is the definition. So when you take modulus of it, mod n cap is 1. So mod A cross B formula is this. So from this, when you find sine of angle between AB, this is the formula. Learn this formula, A cross B, mod A cross B, sine of angle between A and B. Then when you take B cross A, according to this definition, it will be like this. So A, B, n cap form a right-handed system. Then B, A minus n cap direction will be downwards, minus n cap. So B, A minus n cap will form a right-handed system. B, A minus n cap. I am keeping my right hand like this. So minus n cap also form the right-handed system. B, A minus n cap form the right-handed system. So B cross A will be like this. So it is nothing but minus A cross B. So the property that you should learn here is, when you interchange two vectors in the cross product, you must change the sign. If I write B cross A, I should change the sign. Like how you have in vector. Suppose I have AB vector. Suppose I have AB. When I have AB, if I interchange these two, then it is interchange terminal point and initial point, we'll write minus BA. In the same way here also, in cross products, when you interchange the two vectors, you should change the sign. Okay, next A cross A is 0. As I said, when the two vectors are 0, the angle is 0. So its value is 0. So I cross I is 0. J cross J is 0, like that. Next I cross J is K, because in the coordinate system you have I is like this, J is like this. So the perpendicular vector to both I and J will be K. So K is the vector which is perpendicular to both I and J. So that is K. So I cross J is K. So again here, when the rotation is from I to J to K, like that, you will write the third vector. So it is J cross K. J and K are in this direction only. So J cross K is I. Similarly, K cross I will be J, like that. Suppose I interchange. Suppose they are not in that cyclic order. Suppose I have J cross I should write minus K. J cross I is in this direction now. So I should change the sign. Similarly, or you can think of this formula. J cross K is I. So minus K cross J. When it is K cross J, it will be minus I. When you interchange, you should change the sign. Similarly here, I cross K will be minus J, like that. So these are some of the properties. Now we'll discuss some more properties. Suppose that A cross B. Next property is, suppose that A cross B is equal to 0. Next, fifth property, suppose that A cross B is equal to 0. Then it implies either A is 0 or B is 0, or sign of angle between A and B is 0. Suppose A and B are non-zero vectors. A and B are non-zero vectors. Then A is parallel to B, or A and B are collinear. So this implies A is 0 vector, or B is 0 vector, or A is parallel to B. A is parallel to B. So in problems, if we have to show that two vectors are parallel or collinear, you can just show that their cross product is 0. So in dot products, they are perpendicular. If A dot B is 0, A is perpendicular to B. If A cross B is equal to 0, then A is parallel to B. But in first chapter, in addition of vectors, to prove that two vectors are parallel or collinear, we used another method. So here A dot B is equal to 0 means A is perpendicular to B. A cross B is equal to 0 implies that A is parallel to B. Regarding parallel or collinear thing, in addition of vectors, we also proved another property. Another property satisfied by the collinear vectors or parallel vectors, like this. Suppose A is A1I plus A2J plus A3K. And then B is equal to B1I plus B2J plus B3K. Suppose these are two vectors. They are parallel or collinear if A1 by B1 is equal to A2 by B2 is equal to A3 by B3. Or you also have A is equal to lambda B or TB. Any letter you can use here. So we use this property in addition of vectors chapter. But here we have cross product. In cross product also we have similar property. So when two vectors are parallel or collinear, A cross B will be 0. A cross B will be equal to 0. So like this. Okay, now next property is, so A is parallel to B. Now next sixth property I'll write here because we already written A, B vectors. Suppose A and B are given in terms of I, J and K. Suppose A, B, C are given in terms of I, J and K, like this. Then A cross B will be equal to, okay, next I'll write this property. A cross of B plus C is equal to A cross B plus A cross C. It is distributive. Cross product is distributive with respect to addition. Like dot product also we have the similar property. Okay, next suppose A and B are given like this. You suppose you are finding A cross B. Take the cross product term by term and all. You can just learn the formula. You will get like this. I, J, K. And then we'll write I coefficients. I coefficient, J coefficient, K coefficient, A1, A2, A3, and then ijk coefficients B1, B2, B3. So what is this? You will learn about this in matrices. In matrices, this is the determinant symbol for a matrix. This is the determinant symbol for a matrix. Just write this formula. The expansion I'll explain now. See, suppose that you have a 2 by 2 matrix like this, A, B, C, D. The determinant of a 2 by 2 matrix, here these are numbers, these are 4 numbers, and they are placed in the form of a square matrix like this. So the determinant is AD minus BC. This is called as the determinant of this square matrix. So when we put bars, it means it is the determinant value. Suppose I write the matrix A, B, C, D like this. Suppose this is the matrix A. Then implies determinant of A. We write this symbol. Determinant of A is equal to AD minus BC. Okay. Now we'll take one example. Suppose I have a matrix A as 1 minus 3, 4, 1, 4, 3, 2 like this. Then the determinant of A is just multiply these two values. These are called as principal diagonal elements. 2 into 1, that is 2 into 1 minus, or else 1 into 2, I'll write 1 into 2 minus, these two elements you multiply. 4 into minus 3. So it is 2 plus 12, that is 14. So this is called as the determinant of a 2 by 2 matrix. This is how we find the determinant of a 2 by 2 matrix. Now the determinant of a 3 by 3 matrix. The determinant of, suppose you have A1, A2, A3, and then B1, B2, B3, and then C1, C2, C3. This is a matrix. Suppose that this is the matrix A. Then the determinant of this matrix, is denoted by the symbol 2 bars. You must write bars between A, or you can just write bars directly like this also. So this is given by A1, first row elements. You multiply the first row elements. So A1 into their cofactors. Cofactor values are found like this. See, A1 is here. So delete the row and column containing A1. Delete the row and column containing A1. Then what is the matrix left out? It is this matrix. So you write that matrix here. B2, B3, C2, C3. Okay, first element into, delete the row and column. So that value you will write, the determinant. Then for second one you should write minus A2 into, again determinant of, A2 is here. So this is called, these are rows. These are called as rows and these are called as columns. So delete the row and column containing A2. Delete the row and column containing A2. Delete the row and column containing A2. Then what is left? B1, C1, B3, C3. So you write B1, C1, B3, C3. And then plus next third element A3 into. Now second one is minus. Remember this. First one is plus. Second one is minus. Third one is again plus. Why it is like that? All that rules you will learn in matrices chapter. For the time being, you just learn the procedure to find the determinant. So it is delete the row and column containing A3. Then you have B1, B2, C1, C2. So it is B1, B2, C1, C2. Like that. So now you just use this property and write the determinants. So determinant of 3 by 3 matrix is A1 into B2, C3 minus B3, C2 minus A2 into B1, C3 minus B3, C1 plus A3 into B1, C2 minus B2, C1. This is the procedure to find the determinant of a 3 by 3 matrix. Now in the same way here the formula will be, this is equal to A2B3 minus A3B2. So what you do is, you understood this method now. So in the same way you write, and directly writing this step here. So it is minus A1B3 minus A3B1 into J plus A1B2 minus A2B1 into K. So this is the formula. Learn the procedure, how we are finding the determinant. That is very important. You just practice all these points. In the next period, we'll continue with the problems.